Okay, now that was 2 columns down, 1 column to go, our last column. So now that you have filled in the second column in both the Q and the R, we are going to find the last column, Q3. So it's going to be the same procedure. There's a formula at the top before we fill in these columns. That's the formula for Q3 without the hat. That's where we take A3 and we subtract 2 projections. So there are 2 terms being subtracted from A3. The first term has a Q1 transpose A3. That number is going to go there. So look at this Q1 hat. If we do take that, turn it into a row and multiply by that column, or find the inner product of this column with A3, that should give us the number 2 over square root 6 that goes right there in that place. And then independently of that, if we look at the inner product of this column, column 2 with our A3, that's going to be the negative 2 over 15, all of that square root. That's what's going to go in this place. And so these 2 places, the above diagonal places, are just storing the scalars, or that inner product that goes in that formula for how to find this. And so those are the column operations that we do to find this. So go ahead and compute those inner products and put them here. Pause. Okay, now that you've put those in there, just like I have, now you're ready to compute Q3. This helps you to compute Q3. The formula for Q3 is you start with A3, this column, A3, and it's minus this number that we're storing here times the first column, and minus the second number that we're storing here times the second column. And so that's a computation that you can do. And again, notice as you do this, just like last time, every time we write a number into these matrices, there's a radical, and some of them are kind of nasty. They're so nasty, it's okay that you can't read the smudges on the whiteboard because you have it on the handout and I don't have to write it backwards. But they're nasty, the numbers that we store into here. But then notice, as soon as we do the computation for Q3 in that formula, all the square roots go away. So if you are working with square roots, then you're making it harder than it needs to be. Find the way to cancel or simplify the square roots and then do the arithmetic. You see that the numbers that you're going to get are nice numbers. A 0, a 1/5, and a 2/5. So do that. Pause. Okay, now that you've done that, the last step is to factor out the norm so that we can normalize. So find the norm of that. Those are nicer numbers. That norm should be a little bit easier to find. That 1 over square root 5. And so factor that out here and then put those entries, the result, right into there. Now that you have those in there, you can check. This is the A equals QR. And if you actually multiply these matrices together, I know the numbers look very bad, but these are, in fact, orthonormal. You can actually do this matrix, transpose times itself, and get the identity matrix. You can do this matrix times this matrix. You will get the original one back. So again, here are 3 vectors in R3. It includes the unit vector in the original given direction, and then these 2 are 2 vectors that are orthogonal to that original direction. That is the end of this example. There are others like this on the homework, and so I hope that it is useful to be able to play these video clips over and over again. I don't expect that anyone gets this the first time, but by the 4th time or so, we should be comfortable with this. So that's why we have the homework. I wish you the best.